Hello everyone, this is Krishnaveni from Sedu Institute of Technology. Now we are going to discuss about the topic design concepts in software engineering methodology. Software design concept means the idea or principle behind the design. It describes how you plan to solve the problem of designing software, the logic or thinking behind how the design of software. Fundamental software design concepts provides the necessary framework for getting it right. A set of fundamental software design concepts provides the software engineering with the foundation of the software. Design concepts helps you answer for the questions like what criteria can be used to partition software into individual components, how is function or data structures detail separations of the software, what uniform criteria define the technical quality of the software design. Design concepts consists of 12 concepts. The first one is abstraction. For each problem, we may give the solution through modularity. When we consider a modular solution, the levels of abstraction is involved. At the highest level of abstraction, a solution is stated as a broad terms of the problem environment. At the lower level of abstraction, the detailed description of the solution is provided. Finally, at the lowest level of abstraction, solution is implemented directly. There are two types of abstractions are data abstraction and procedural abstraction. Collection of data that describes the data object, that is a set of attributes, is called data abstraction. For example, door. It encompasses a set of attributes like door type, weight, dimensions, etc. Likewise, procedural abstraction means the information contained in the attributes of the data. So these are the two types of abstraction. Second concept is architecture. Software architecture means the structure of program components, the interaction between the components, and structure of data that are used by the components. The main goal of the software design is to serve a structured framework from the detailed design activities. It helps the software engineer to solve common design problems. These are the part of an architectural design: structural properties, extra functional properties, and families of related systems. Structural properties define the components of the system. Extra functional properties describe the address how the design architecture achieve the requirements, and families of related systems or patterns that are commonly encountered in the design of the families of similar systems. So this design should have the ability to reuse the architecture. Third concept is pattern. Design pattern describes a design structure. It fixes a specific context for solve a particular design problem. Before we start a design pattern, the designer must determine whether the pattern is applicable to the current work, whether the pattern can be reused, whether the pattern can serve as a guide for developing a similar but functionally or structurally different pattern. The next concept is separation of concerns. Any complex problem can be easily handled if it is divided into the pieces. These subdivisions can be solved independently. So this concept is separation of concerns. For two problems, P1 and P2, if the perceived complexity of P1 is greater than the perceived complexity of P2, then it follows that the effort required to solve P1 is greater than the effort required to solve P2. The fifth concept is modularity. In the previous concept, the subdivisions are carried out to solve the problem. So these divisions are separately named, and addressable components means then it is called the modules. When we modularize a design, developments can be more easily planned, software increments can be defined and delivered, changes can be easily accommodated, testing and designing can be conducted efficiently, and long-term maintenance can be conducted without serious side effects. Sixth concept is information hiding. Principle of information hiding suggests that modules be characterized by design decisions that hides from all others. Information contained within the module is inaccessible to the other modules because they no need to know such information. This specification is called the information hiding. So when we hide the information of modules, we can achieve effective modularity. The next design concept is functional independence. Functional independence is achieved by developing modules with a single-minded function and an interaction with other modules. So independence is assessed by two qualitative criteria: cohesion and coupling. Cohesion is an indication of the relative functional strength of the module, and coupling is an indication of the relative interdependence among the modules. Next one is refinement. Refinement is actually a process of elaboration. It starts from the statement of the function to the high level of the abstraction. Here the statement describes function or information, but it will not provide information about the internal structure of the information. Refinement is elaborate on the original statement, providing more and more detail as each successive refinement. Abstraction and refinement are complementary concepts. Abstractions enables the procedure and data internally. Refinement helps you to reveal low-level details as design progresses. The next design concept is aspects. The idea of the aspect is implemented as a separate module rather than the fragments, because the fragments or the components, it may be scattered. So the idea of aspect is implemented as a separate module. Design architecture should support a mechanism for designing an aspects. The next design concept is refactoring. Refactoring is an important design activity for many agile methods. Refactoring means reorganizing the techniques, that is, it simplifies the design of a component without changing its function or behavior. When the software is refactored, the existing design is examined for redundancy, insufficient algorithms, inappropriate data structures, or any other design failures. The next design concept is object-oriented design concepts. The object-oriented paradigm is widely used in modern software engineering methodology. So, object-oriented design concepts such as classes and objects, inheritance, messages, and polymorphism, among other concepts, are included in this object-oriented design concepts. The final concept is the design classes. Requirement model defines a set of analysis classes. Each describes the element of problem domain and focusing on the aspects of the problem. For a design model, we have to define a set of design classes, refine the analysis classes, then it will enable the classes to be implemented. Here there are 5 different types of design classes, and each representing a different layer of the architecture. The 5 different layers of design classes are user interfaces classes, it will define all abstractions. Business domain classes are often refinement of the analysis classes. Third one is process classes, it implements the lower level business abstractions. Persistent classes, it represents the data stores. And system classes, it implements the software management and control functions that enable the system to operate in the environment. Thank you.